So, good morning, guys. My name is Sagar Sonane, and along with Shushmita, I'll be taking your session for today. In yesterday's session, you had learned about pointers, interfaces, and methods in Golang. So today we'll be covering few more topics, and some of them are error handling, defer statements in Go, panic and recovery, contexts, and Go modules. So let's get started. First, can someone confirm if this font size is visible to you?
Yes.
Okay, thanks. So first, see like one of the simple programs which we have been working on for past few days, and how does it look like? So I have written a function to divide two values. So it generally takes two inputs. It performs the divide operation and returns the output value. So this is it. This is how a divide function should work, and it is working as expected. Okay, but as we can see, there is a possibility of error here, that if I like send a zero value here, so this would cause a divide by zero panic in our program, because it is not acceptable to have zero in the denominator while performing divide operations. So if I do not handle this case in any way, our program is going to be in panic state and it will throw a panic. So what can be done in this situation? So in Golang, this is where error handling comes in. So generally in another programming languages, you must have like seen try catch to handle exceptions and errors, but Golang has it very simpler. So in Golang, we generally handle errors by returning values and not raising the exceptions. So errors in Golangs are just values, just like integer or a string or any another data type. So let's look at the program given here. So as you can see in the function main, I have called a divide method. And if you see the method signature of this divide method, you will see in the return parameters, I have sent two values here. The first one is an integer value if the result is correct, and second one is error in case of any exception. So I have like written a condition to handle this denominator zero situation. So if the denominator is zero, what I am doing is I am returning the zero value for the result, and I am returning an error, so that I know in the main function that this divide function did not execute it properly and throw an error. So let's try to execute this program and see how it goes. So what I have done now here is I have just added another parameter to return values in the divide function. So this is returning an error in case we are sending denominator value 0. So in case of 2010 as parameters to divide function, this should run properly, since this is not an error condition. So I'll just catch the value here and we'll try to print out. So as you can see, this divide operation is working properly, and it is giving us the output 2, since 20 divided by 10 gives us the value 2. But in case if I send a value 0 here, so what our divide function should do is it should like satisfy this condition that b equal to 0, and it should return an error to us. So this second parameter, which you guys can see, this is how we create an error and we are returning it to the caller function. So let's try to run the program. And as you can see, our divide function returned an error, that is can't divide value 20 by 0. And here we have done the error handling. So since we encountered an error in the divide function, we have checked if error is not nil. So that means if if we have got an error from divide function, and in that case we have handled the error and printed some string along with it. So I have printed error occurred, and after that whatever error I have got. So this is the general way of doing error handling in Golang. So let's see more about it. So error type in Golang is a standard error in Go. So we have a error type which is there present in the standard library, which is generally used as error in Golang. So this is nothing but an interface. So you guys must have learned about interfaces yesterday. So this error interface consists of error string. Okay. So any type which satisfies this interface can also implement the error type. Okay. So we'll see the example in later slides. So first, we will see how we can construct errors in Go. So generally, there are two ways to construct errors in Go, and these two methods are provided us by the inbuilt packages in Golang. And one of them is errors package, and one of them is fmt package. So in errors package, we have a method errors.New. So let's look at the documentation here, what it tells us. Okay, so what this error function is doing is, it is just returning an error string object with
Here's what I found.
No, sorry. So just let me zoom in the screen. Okay. Is the font size visible to you guys now?
Yes.
Okay. So as you can see, I just mentioned that our error type is an interface. So what this built-in function has done is, it has an error, sorry, it has an error string struct, which consists of a field that is of string type. Okay. And on that method, on that type, we have written a error method, which returns a string. So since the method signature is same for what we have in error interface, so this is satisfying the error interface for us. This error string type is satisfying error interface. That's what we are doing here now in the new function. So what this new function does is, it takes a string and returns us the error string object with text value. So since it satisfies the interface, it was passable through the return parameter. Since this error is an interface type, and this error string satisfies the interface, so we were able to return this error string object along with the text value which we were given through the function. So this creates an error object for us. So this errors.new method is used to create an error using errors package. And another one we have is error.Errorf, which is there present in fmt package. So this errorf is used when we want to achieve some formatting in our error messages. So errors.new is looks very much plain and simple, that you need to just pass on the string, and it will raise the error with this value. But if you want to generate an error with some formattings, so you can use the errorf method. So let's see with the help of an example. So first what I have done is, I have created a function one which returns an error, and I have returned an error using errors.new method. So I have created a method here using errors.new, and I have returned it to the function one. And within the main function, I have called this function one and catch the value of error in this error value. Okay. And since this is interface, either it can be nil or not nil. Not nil in the cases when we are sending any error value, and it will be nil when we do not send any error value to this. So that's why we are checking here error not equal to nil, to check if we have have got any error value. So if we run the program, we will see that it is printing error, something went wrong, which is our error message. So this error method returns a string only. So that's why we were able to see this message inside the error handling part. So now let's do it for another function. So this is pretty much similar to the function one only, but we have used fmt.Errorf in this case. And as you can see, I have done some formatting here in the message, that error number %d and cause of that %s, and I also pass the parameters. So this should return the error and show us the value as error number 1, cause unknown. So let's try to run the program and see. Okay, so what is the problem here? Yes. So error variable is not declared. That's why it was giving us error. Okay. So as you guys can see, we have got the error output here, which is error number 1 and cause unknown. So this is how you can create your own errors in Golang using errors.New method and fmt.Errorf method. So you can also define expected errors. So what do I mean by expected here? Errors here is, so consider, there is a possibility that in this particular case, I have created a variable for divide by zero error. So consider a possibility where that your function might encounter this particular kind of error. So what you can do is you can declare a global variable and assign this error to it and use it wherever you want to create the error for divide by zero or either handle it. So let's take a look. So one more thing before going ahead with the example, there is a functionality we can use from errors package to compare two errors. So here in this example, what we are trying to do is we are trying to throw this error divide by zero, and we will try to catch that by using this name only. So in order to do that, we will need to compare these two errors, the one which we returned and this particular one. So this error.is function is used if you want to compare two errors. So this error.is takes two arguments. First one is error and second one is target value, and both are of error types. And it returns a Boolean value, true if error match and false if error does not match. So let's see. So here what I have done is I have created a exported variable error divide by zero, and I have assigned the value here errors.new divide by zero. So I have declared an error variable here. Okay. So in my divide by zero function, earlier what I used to do was I used to create a new error here with the help of errors.new or fm.Errorf. But instead of that, now I know that this error has occurred due to divide by zero condition, and I have already defined an error for it. So what I can do is I can just use this error variable and send it instead of creating a new error message again and again. So I have done the same here. I have written this error divide by zero in case we encounter denominator value as zero. And within the main function, what we are trying to do is we are doing the error handling part. And within the error handling, that is error not equal to nil, and which means we have got the error from divide function. We have just applied a switch case, and in the switch case we have a case where we are checking the error we have got from the divide function is similar to divide by zero condition. So these are two error type objects only. One we got from divide method and one we already have as an exported type. So we are just comparing it, and we will print divide by 0 error. And if error is something else, it will just print that unexpected division error, and it will print the value of that. So let's just run this program. And as you can see, we have got the divide by error 0 error, since both of these values matched. And let's see if I like do something new here. I create a new error and give it any name like some error. So this should not match, and go to the default case within the error handling part. So yeah, as expected, we have got the unexpected division error, and it is showing us the error message. So this is how we can like define our own errors using the exported type and use it anywhere we want, even to like send the error messages or even while handling it. So this error.is method is used to compare two errors. And someone is asking, can I repeat errorf? So this is pretty much errorf is pretty much similar to what we saw in like fmt.Printf or sprintf. So we used to like do the formatting of the string. So this is similar to that only. So what we are doing is we are just creating an error message with a formatted string. So you can also consider fmt.Errorf as just let me show you. So in the function, I have fmt.Errorf used. So instead of this, what I can also do is I can create a string of my own, like error message of my own, and use the same value. And then I can pass the string error message, and this will work similar to what we have in form.error So just in order to see the change in output, I am just adding some string here. So you guys can see that error messages change now, but it is similar to what we got for fmt.Errorf. We just added formatting to our error message. That's it. So yeah, as I mentioned, the error type in Golang is an interface type with one method, that is error, which returns a string. So any type which like satisfies this interface, we can create a custom error for that. Okay. So let's see with the help of an example. I've seen a question in chat box. What if there are two errors with same string? What will compare return? So it will return the same value. What if there are two errors with same string? What will compare return? Okay. So since the error will be same, it will like return true only when compared. You can also see Shushmita's answer in the chat box while I continue with the uh, custom errors in Golang. So yeah, let's see. So right now what I have done here is I have created a struct of my own, which is error message, and which has two fields. One is status code and one is message. Status code is of integer type and message is a string. So since error is an interface only, which has a method error and returns a string, so any type which satisfies this interface can implement the error interface. So what I've done here is I have just declared declared the error method on this error message type. And what I am returning from here is I am returning message colon percentage s status code colon percentage d, and uh, replacing percentage s and percentage d, we have message and status code. So the final error message should be formatted like message colon message value and status code colon status value. So if I like yeah, in the test func, I have returned an error message with the values 400 and invalid request body type. So since this error message type satisfy the error interface, it should represent the error. So since it is passing error only, so the return value is error, and I'm returning error message type here. So since this satisfies the interface, it will be able to pass through. Okay. And in the error handling part, we have just print the error message. So let's see what's the value here. So we have not used fmt.Errorf, or we have not used errors.New here, but instead we defined an error message of our own with the help of custom type. So we were able to do that since it was error is an interface type only. And once we like define an error method on any type, it can implement the error interface. So that's why error.Error here has not printed the simple error message, but it has printed the message which we defined. So as you can see, it is showing message colon invalid request body and status code 400. So this is how we can create our own custom messages in Golang. So if you have a type of your own, you just need to define a error method on it, which has the similar method signature, and you can return any type of string you want. Like if you want to add some stack trace here, or if you want to add any specific message, just like what I did here, instead of just having message, I added the status code also. So that's how you can also create your own custom messages in custom errors in Golang. So in order to get the original values of the concrete type, we can use error.as function. So in this particular case, what I did was I created a object of error message type. Okay. And I passed it around as error. Since it satisfied the error interface, it was able to pass through. But what if I want to get the concrete values back and do perform some operation on it? So I can do that with the help of error.as method. So this is also a method provided by the built-in package errors. And let's see how it works. So what I need to do is I need to pass two values to error.as function. And first value is the error and second is the pointer to the concrete type. So what do I mean by pointer to the concrete type? So the concrete type of our error is error message here, since we created a custom error. So in order to get the values, in order to get the real values back, like I created a custom error message here with message value invalid request body and 400. And if I want to get these values back into a struct type, like into a struct object, so if I to see, you will be able to see that we were able to fetch the values from error into error message object, and we were able to separately print the message and status code. So this is how we can like create custom errors in Golang along with using error.S function to get the concrete values back. So there are few good practices around error handling in Go. So whenever you are like writing a function which returns an error, and in the caller function, you should always check the error value, since it can be anything, like any uh, abnormalities would have happened in that program. So in order to like your program to not crash, you should always check the error returns from the functions, so that you make sure that errors are handled properly. And secondly, early return at place of if else with error values. So consider what I have done here is, so just let's look at another example. So what I have done here is, in the divide function, I am returning an error. So in case I encounter an error, what I am doing is I am just handling the error, checking if it is not nil, and uh, printing the error, or if I just want to return the error forward to another caller function. So in that case, what I should do is I should also add a return statement here. So what this return statement will do is, this will stop the execution here only, and will go back to the caller function, because since we encountered an error at this part and we do not want to continue further, so this will just return back to the caller function. Okay, so this is how early return works. So whenever you like encounter an error and you want to do not continue anymore, you should do the return in the error handling part, so that any other code which is after that particular error handling case, this should that should not get executed, because the earlier condition failed. So yeah, while writing function, while writing functions, it should be kept in mind that error error uh, error values should be the last return parameters. So this is a best practice kind of thing in error handling in Golang. So whenever you are returning an error, it should be like the last returned values. So in this case also, in this divide method, what I've done is I have sent the value of the result first as a first parameter, and I have sent the value of error as last parameter. So it is generally a best practice to do it this way, to return the error value as last parameter. And define and use unexpected use expected errors. So we saw the use case of expected errors when we know that this kind of error could happen. So it is a good practice to have expected errors in our code and do error handling around it, and return zero values of other params if error is not nil. So in case just like what we saw in this divide case, what we did was we returned an error, as well as the result value we set it to 0, because in case we got an error and we did not handle it here and we use the value as it is, so there is a possibility that this value is not correct. So that's why whenever we like do the error handling and create an error in our functions, so it is a best practice to like set the 0 value for the other return types. So in that case, we make sure that we do not send any uh, unnecessary or incomplete information to the caller function. And the last one is just writing good error messages. It helps with debugging. So you can add several values to it related to trace, like in which function this error occurred, or something like that, so that your error message looks good and it helps in debugging the program. Okay, so let's continue with the other part. and that is defer statements in Go. So there are defer statements in Go which postpones the execution of a function until the surrounding function returns. So consider a case where you want something to be executed at the very last. So let's look at with the help of an example. So yeah. So consider I want to like the right print this hello world at the start of the function, and I want an end world at the end of the function. Okay. So what is the general case for doing that? That I will do the I will print the end world value at the last. So this should like print the end world at the very end of the function call, right? Okay. But what if my function panics within, or if there is any other code within between in between this, and that returns an error and like crashes out of the program or returns to the caller function. So what to do in that case? So for that particular case, we have defer functions, defer statements in Golang. So what defer statement do is it it postpones the execution of the surrounding function. It postpones the execution of the function until the surrounding function stop execution. So let's consider I want to let's look at an example first. Like I, I'll put few more print messages here. So I'll write print one, then print two, print three, print four, and after that I will run this program. So what is the sequence of execution here? Hello, print one, print two, print three, print four, and end world. But what if in any case my function returns early without reaching the point to the end world? So in that case, this particular part will not get executed. So as you can see, it has just printed hello world, print one and print two. But my use case is to print this end world every time when the function ends. So in that case, we use the defer statements. So what I'll do is I'll just take this one up and I will append a defer keyword in front of it. So what this defer keyword will do is it will put this println function call in the stack, and it will unwind the stack when the main function or surrounding function, to be precise, stops its execution. So you can see in the output here that it has now printed hello world, print one, print two, end world, because as soon as this function hit return, it started unwinding the defer stack and it printed this message. Okay, so this is how defer keywords work. So what they do is they just postpones the execution of a particular function until the end of the surrounding function. So in this case, my surrounding function was main, and the function I wanted to execute was fmt.Println. So what it did was, as soon as the main function hit return, it unwind the stack defer stack, and it started executing the functions which were there in defer. So yeah, the syntax is very simple, as we just saw, that you just need to append defer in front of the function call, and just like that we can execute the defer functions. So order of execution of defer functions is last in first out, since the stack data structure handles the function calls in background. So the function call that goes last within the stack comes out first. So we can have multiple defer functions in our defer function calls in our Golang. So that's why the last in first out execution sequence is followed for the multiple defer calls. So let's see with the help of an example. So right now what I have done is I have I have iterated in a for loop which ranges up to the value 0 to 9. And what I have done is I have like first I'll do it without using the defer keyword. So what this is supposed to do is it is printing iteration 0, iteration 1 up to iteration 9. But what if I append defer to this function call? So what this will do is this will reverse the execution order. So the print ln iteration 0 went into the stack first, then after that iteration 1, then iteration 2. So as soon as this function ended, the defer stack started unwinding, and the last value which it got was iteration 9. So it start popping out values in the last in first out sequence. So that's why we get to see this iteration sequences iteration 9, 8, 7. So let's suppose uh, in case of opening and closing file, so how this can be proved to be helpful. So what is the general execution sequence if we do not use defer here? That we open the file of one, we open the file two, then after that we open the close the file one, close the file two. Okay, so this is the normal sequence. But if I want to mention the closing file sequence just after opening it, so in that case defer comes in very handy. So you do not have to like manage the closing of files, and you do not have to like remember the sequence of it. You just have to close the file as soon as you open it, and append a defer keyword to it. So what the defer stack will take care of it, and as soon as the function ends, it will just start closing the file in last in first out manner. So consider I had opened one file to read from. So I opened file number one, and then I wanted to copy the data from file one to file two. So what I did was I opened the file two for that. So after I was done copying the data from file one to file two, what is the proper sequence of closing file is I close the file two first because I am done writing into it. Then after that, I close the file one because I am done reading after reading from it. So this is uh, this is the reason why defer does it in the last in first out manners. So what I have done here is I have just represented the opening and closing file with the help of an print statement here. So this first print statement represents that we are opening a file for some operation. Then after that, right after that, I have added a closing statement for file also, but with defer keyword. So unless this main function is done with the execution of all its program, it will not roll back the defer call. So as soon as this main function stop executing, like it is done with opening file 2 and copying data from file 1 to file 2, it will start closing the files in last in first out manner. So as you can see in the output, open file 1, open file 2, close file 2, close file 1. So this is how the order of sequence works in defer in case of defer statements. So yeah, one more thing while working with defer, we need to keep in mind is argument evaluation. So the argument evaluation are done immediately, even though function call is not executed until until the surrounding function returns. So even if the surrounding function does not return, whenever we are declaring the defer function, the argument to that defer function is calculated at that time only. So let's see with the help of an example. So what I have done is I have used a value 1 here. I have declared a variable I and assigned a value 1. And I have uh, called a print num function. What it does is it just prints the string num and the value of number. So I have attached a defer call to it. So even though this execution of this function will happen at the very last of the main function, but the argument evaluation will be done at this point only. So at line number 13, whatever is the value of I we pass to print num function, it will print that value only. Okay. And let's see the output of this program. So first, let's see the sequence of program. First, I have uh, created a variable and assigned a value 1 to it. Then after I did a defer call in which I have called the print num function with the value of I. So what it should do is it should uh, like send the print num function into defer stack. And after that, I have printed a first main statement. Then I incremented the value of I, did a defer method call again with the new value of I, and I did a defer call again for I multiplied by I. So at this point of time, at line number 13, the value of I equal to 1. At line number 16, what I got the value of I is 2. And at line number 17, I did the multiplication operation. So the value of I got was 2 into 2, that is 4. So the order of execution should be, first it should print the first main statement. Then after that, it should print num value 4. Then after that, it should print num value 2, and then it should print num value 1 because of the reverse order of execution. So as expected, the first main statement, then after that num 4, since it was last inserted into the stack, second num 2, and then after num 1. So this thing needs to be keep in mind that the arguments passed to the defer functions are evaluated at the time of function call only. So at the time we have defined the defer function. Okay. So let's just go through once when are the defer statements executed. So generally we saw one of the cases that when a return statement is encountered in the caller function, the defer stack starts rolling, and it start executing the defer functions. Okay. And a second case is when the enclosing function falls off. That means it has executed all the instructions that were there in the program. So uh, consider in this particular main program. So let's take an example of this prompt dot. So what I have in this print term function is I have two print statement. So as soon as this print statement is done executing both these two statements, we can say that it has fall through. So that means it has done the execution of all the instructions that were present in this function. So this is what we mean by fall of here. And the third case, when the enclosing function, and the third case, when the defer statements are executed is panics. So in case a panic occurs in our programs, so at that time also defer stack starts unwinding, and it starts executing all the functions in the defer stack. So let's look at an example for all the three. So just I have created three functions in order to help us with the example. So first function I have is encounter return. So in encounter return function, what I have done is I have first put a statement into defer stack, that is open resource. Then after that, it is supposed to be closed source though, because we want to, yes. So in the first print statement, I have open resource. Then after that, in the defer statement, I have close resource. And then after that, if true condition, and I have returned from this function. So this condition will be always true, since we have passed true in the if condition. So this will not go forward at the point where we execute line number 23 and 25, and it will return from this point only, from line 20 only. So what it should print is, it should print the open resource one and close resource one only. Yeah. So let me put it just above the open resource so that we know that this is executing in reverse order only. So the order is unchanged. That means the print open resource is anyways executed first, and defer close resource function is executed last. So now let's look at the fall off function. So fall off function is pretty much similar to the one, but we just did not use return here. So the false of function has four statements: fm.println open resource, defer close resource one, open resource two, defer close resource two. So as we print this, we will see the output as open resource one, open resource two, close resource two, close resource one. So since the function execution fall off after line number 33, so the defer stack started unwinding and executed all the necessary functions that were there in the defer stack. And third case is when the program panics. So in case any panic occurs in our program, panic is an abnormal condition which generally is cannot be handled, generally is not handled. So any expected thing, like we saw one case before, that divide by zero error. So we could not have like predicted that compiler is gonna fail at that time. So sometimes panic occurs in our program. So at that time only, at that time also, defer statements are useful to close the resources. So in case panic occurs, we have defer statements to close the open resources. So let's see, this example is pretty much similar to the one we saw earlier, that we open a resource, then put close resource into defer stack, again open resource to close, put the defer, put the close resource to in defer stack. Then after that, we like created a panic. Okay, so let's see how the output is. So as you can see, the output execution is similar from the previous one, which is it opens the resource first, opens resource two, and as soon as it hits the panic, it start unwinding the defer stack and it start closing the resources. And after that, it stopped the function execution, like it stopped after this, but it let the defer statement to be executed, because we might have like added some functions to close the resources into defer stack. So that's why it is important to like unwind the defer before panicking the before panicking our program. So this is how we can, this is the play, this is how defer statements get executed when the function execution, surrounding function execution stops. Yeah, so there is one more thing with defer, that when used with anonymous functions. So when we put an anonymous function into defer stack, we can modify the surrounding functions name returned. So let's look at the example which is shown here, that we have a foo function. Okay, and foo function returns the result string. Okay, and in the program you can see I have put an anonymous function call into defer stack, and what this anonymous function is doing is it is assigning the value change world to result variable. And just after this defer statement is executed, we have a return statement which returns the hello world in the string value. So in this case, the result value, the result return parameter will not have the hello world value. It will have the change world value because it is doable in this situation using anonymous function. So with the help of anonymous function, we can change the, we can modify the surrounding functions return values. So let's see it with the help of example. So this is we just saw. Okay, sorry, was supposed to run it. So this foo function returns a string. So I'll just take this value and print the value of this return here. So this is change world only. Or if I want to like update it to end world, I can also do that here. So the use case can be many for this anonymous using anonymous function with defer, but generally it is used to update the value which we want to return. So in case we want to handle errors, we can also do that, like we can put error message in defer, error conditions in defer. So if I like execute some function calls here and I do not handle the error values, and in, so let's see the example only. So I have a function divide. So
Hello.
yeah,
Sagar, can you re-explain the order of execution of this program, like in the anonymous function, like how it executes?
so it is same only. It will be executed in the as soon as the return function is hit, it will start executing the defer statements. So as soon as we hit return, so what we did was in the return we set the result value to hello world. Okay. So after that it will start unwinding the defer stack. So in the defer function, in the defer calls, we have an anonymous function. So what this does is it changed the value of result to end world. So that's why we were able to get the value end world instead of getting the hello world here. So the order of execution is that only. As soon as return is hit, it starts unbinding the defer stack and executing the functions in the defer stack.
What if like we don't mention that result will be the variable which will be returned and only write string here, and then we can add another return statement here, in line number 16. Like
And
we are telling the compiler that result will be the returned value. So what if we don't mention that and only tell that it will be a string, and in the defer function, can we re-return?
sorry, I'm not able to get what.
Like on line number 14, if we don't write result will be the returned variable.
Okay.
Line number 14.
Okay, on line number 14.
Yeah, so if we remove that and only tell that it's a string that will be returned, we don't tell the name of the variable which will be returned.
Yeah, let's see.
So
So yeah, so since result here was
no, like we can we re-return here on line number 17 without defining?
on line number 17, by not defining, by what do you mean by that? Sorry, I'm not able
can you remove the line 15 completely?
Okay.
And then when we are trying on line number 16 to result to hello world, can we re-return, like can we write return end world here?
Okay, return end world. Okay. So you cannot do that because anonymous function does not have a return.
No, brackets are there in line number 14. You have to remove the brackets, I think. 14.
No, that won't matter.
I think that
you see, this is giving error in anonymous function. So this anonymous function also has a method signature, right?
Yeah,
That
in that
is,
also we can write string as a return value.
so in this case, it is not doing the hello world because it does not know the like value which it is trying to catch. So since it was a named return, okay,
Mhm. So
well,
like
name,
both
and
of them
we
are
knew the
trying to
variable
return.
location which we wanted to update. Okay, okay. So sorry.
Both of them are trying to return. We change the return value through a named return, but now we are not able to change. Like, why is it so?
Because we are not specifying the memory location, because since we used the name return here, okay, so it we knew that this memory location was specific that we wanted to change using within this anonymous function, right?
Okay.
Okay, so since we had this result variable, so it must have allocated a memory for this, okay, and as soon as we like tried to do this, so this knew that we were trying to change the value at this particular memory location, which is pointed by result variable. So that why it was able to catch the value. So this is a closure concept, So in anonymous functions, you can use uh, out of the scope values as well. So those out of scope values are pointed here, like used as pointer. So this result is treated as a pointer, and we are updating the pointer value to end world. So if
What do you mean by out of scope value?
out of scope, as in this function, this anonymous function has its own scope.
Okay. Okay.
That's why. That's what I'm trying to say. Did you get that?
Yeah, good. Thank you.
Okay, sure.
Hi Sagar, I have a question.
Yeah.
So when Yes told you to change the return type, like it was returning 2 times in this foo function. So why it didn't show the error?
So there is no cause for error, right? Because even though we do not handle error value, it this function was still gonna get executed. So if I like consider I have this foo function here. So do you see any error here? Even though I did not like catch the returned values from foo. So that is why the error did not happen. So it is like not mandatory that you catch the value whichever is returned from the function. So that was the reason why error did not occur, even though we like did not catch the value for the anonymous function return. Is it clear?
So like I am asking, can a function return two times?
Can a function return 2 times? So how do you mean by that? Can you like guide me?
So when we remove this result in line number 11 and just return end world,
Okay.
then at line number 14 we will return hello world. Then again when defer function executes, we will return end world. So we are returning 2 times.
Yeah.
So
So
it creates some problem.
no, it will not create any problem because this is a separate function altogether. This foo function is different and this anonymous function is different altogether.
Yeah, got it.
Okay.
Yes, thank you.
Welcome. Okay. So yeah, just we just saw that anonymous function use. So we can like use the outside variables inside defer functions as well. So as you can see in this example, I have like written a for loop and I have added a anonymous function into defer call here. Okay, and I am trying to print the value I. So just let me open this into playground so that we can like see the execution as well. Is it the same? Okay, yes, it is same. So what we did was we uh, added a anonymous function into defer stack here. So what it did is it prints the value of I. So even though this value of I at this point of time is 1, but still when you like print this run this function, it will print 2 because this for this function, okay, for this function I is out of scope, and this represents the concept of closures in Golang, that this function can access the out of scope values. So for this particular function, this I is out of scope. So that's why when this for loop is done executing, so after this for loop is done executing, the value of I is 2 at the end after the loops are executed. So when the defer stack rollbacks, since it is pointing to this memory location and it is not pointing to the value, so it will print 2 for both the cases, which we just saw in the one case back for the question which was asked. So this concept is related to closure. So that's why we were able to get the value 2 and not 2 1 here. Okay. So this can be helpful in some cases, like let's see one example here, that I have a long running function and I want to log the time it took to get executed. Okay. So what I did was I started in the start of the function, I created a start variable. Okay. And that start variable, I assigned a time.now value. So time.now value assigns the current time to this variable. Okay. And in the defer, I added a anonymous function, which what does is it prints the value of function took %v to execute, and it calculates the value time.since start. So what this time.since does is it calculates the duration from the start value. So since I added a time.sleep at the end, you'll be able to see that this function took 3 seconds to execute. That means, just let's see with the output. So this function took 3 seconds to execute. That means we were able to get the value of this start when the function when the function has ended and not at this point. So if we would have gotten the value of start here, it would have been some milliseconds only. But since we are getting using the concept of closures here, and we are using the reference of start here, it is using the memory location of the start to get the value. So as soon as the function stops execution, it will get whatever value the start has. So after the function is done executing, value of start would be 3 seconds older. That's why we were able to get the time.since value as 3 seconds and not just some milliseconds. Okay. So for this case, if I just remove this anonymous function, the distinction will be clear, and you guys will be able to see that the function took 0 seconds to execute because the arguments are evaluated at this time only in this particular case. But in case I use an anonymous function here, and within that anonymous function, I am getting the value of start, it is referring to the latest value of the start variable, and which is 3 seconds older. So that's why I was able to get the time 3 seconds. Okay. So there are few use cases which we should keep in mind while working with defer. So generally defer is used while we want to perform cleanup actions such as closing files or unlocking mutexes. So it is a good practice to write the defer statement followed by open action only. So as we just saw with the help of print statements, that I was opening a file and I don't want to remember that I have to close this file as well. So what I can do is I can just use the defer statement and do the closing action right after the opening action. So this makes our code look very clean, and it also helps us achieve the desired output as well, that at the end of the function file should be properly closed. And there is a very good use case for defer statements, and that is helping with panic recovery. So since we saw that at the time of the code panic, or defer statements get executed, so in that at that time we can use defer statement to recover from panic as well. So we will get to see that use case in few minutes. So yeah, this was all about defer statements in Golang. So let's talk about panic and recover. So like try and catch, we have panic and recover in our Go programs. So panic is similar to like exception handling in Java and Python, where panic is equivalent of throw or raise, and recover fills the role of catch. So in Golang, it is generally encouraged to use error handling to work with abnormal situation instead of using panics, because what panic does is it directly crashes your programs. So it is generally not possible to like it is not recommended to use panic directly, and instead it is recommended that we use error handlings. So yeah, someone has requested that we take a small break. uh, can we do that, Rachel, now? Or Rachel, you there? Okay, after this topic we will take a small 5-10 minute break, and then we'll continue with the other topics. Okay, so this is not going to take too much time, so just hold on for a few minutes. So it is generally encouraged to use error handling and not use panics, because panic like stops the execution of program and crashes it altogether. So let's see what happens when a panic is encountered. So we will see the example moving forward. So let's just see what happens. So when a panic happens in a function execution, the function execution stops altogether. So if my function has 10 instructions to execute, and at instruction number 5 the panic occurs, so what will happen is it will stop the execution of that function altogether, and it will not execute anything after that instruction number 5, and it will start unwinding all the methods in the stack. So all the defer functions are start executing when a panic occurs in a function. Then the function returns to the caller, and the caller also acts like a panic function. So consider I have a function A, okay, and that function A is calling function B, and the function B panicked for some reason. So as soon as B panicked, it will stop the execution and unwind all the functions in the defer stack for that function B, and it will return to the caller A. But to the caller A, that B will also act like panic. So the same activities that happened for B, like stopping execution of instruction afterward and unwinding the defer stack, this will all start happening for A as well. And this goes up until the current go routine is finished altogether. Like until the function returns main and terminates the program, this will go on and on. So and at the end the stack trace will be printed. Okay, so let's understand with the help of an example. So yeah, consider as we can see, there is one function A which first prints start of A, then after that it has a defer function end of A, and after that it calls B. Okay, let's for reference add two more statements. Start of double A, triple A, and end of triple A, and also in case of B, let's do the same. So within the a function, we are calling this printing this start of a, end of, and then after that we are putting a defer statement, end of a in defer stack, and after that we have called b. So this call will go to b, then after that b will start printing the start of b, then after that it will execute this defer statement, and as soon as it hits this panic at line number 26, it will stop its execution, and the statements you see after that, this will not get executed. So let's see what is the output and how it is unwinded. So as you can see, the function executed started with hello. Okay, it printed hello world, then after that it called a, after that it called a, it uh, it print the statement start of a, then after that it put the value in defer. Okay, so it is in defer only right now. Then it went into the call function call b, then it print start of b, then after that it put the end of b in defer, and after that the panic occurred. So as soon as panic occurred, it stopped the execution. That means it did not execute anything after this panic statement, and it started unwinding the defer stack. So as soon as the defer stack started unwinding, the end of b was executed, and the b was returned to caller a. Okay, but as we saw in the previous slide, that it was mentioned that this b will also act as a panic to a as well. So this means that a has also encountered a panic at line 15. So what this will do is, this will also will not execute the statement at line number 17 and 18, and it will start unwinding the defer stack. So it will now print end of a, and this will go to the main function. So now the main function, so like if I print anything here, you can see end of main is also not printed, because as soon as this is it, that means the current go routine is, this main is also go routine. Okay, so it is also treated as panic for main, and main is also stopped executing. So after all the execution of the go routine has stopped, it will create a panic. It will like print a stack trace of panic. So in the stack trace, we can see that panic was first generated at line number 28 in program.go file. So this is what we can see, that at line number 28 panic occurred. Then after that it got propagated to another function at line number 17. So we can verify that b is then treated as a panic, and again the caller returned to main function at line number 9. So we can see the line number 9 in stack trace as well. So this is how a panic occurs, and the stack trace returned by panic statements. So let's see the conditions where a panic occur. So there are a few common causes of panic, and some of them are index out of range error, like you have a array or a slice which only contains 3 or 4 consider it contains only 3 values, but I am trying to access the index 5. So since it does not contain anything at that particular memory location, and it does not have an index for that value, so it will give us the index out of range panic. So as we can see, we have a slice here which has 3 values, and what I'm trying to do here is, I am trying to access the value at 4th index. So it will not print this statement after this, that is normally returned without panic, and this program will panic, and it will give us error, runtime index out of range 4 with length 3. So this is the error returned by panic. Okay, and similar we have for divide by 0 as well. So in the divide by zero case, we saw that when we like divide a number by zero, it also returns a panic for us. So this will also mention that runtime error occurred and integer divided by zero. So this will also specify what panic occurred. And since these panics are compiler generated, okay. So there is a message which we have not specified by ourselves. So we can also create panics of our own. So since we saw in some previous example that I had used a panic function to like represent a panic. So that panic function takes an empty interface as an argument. So this can accept any type of value. So you can send any type of value to it, like string, integer, or any custom type. It will accept and it will return at the time of recovery. So we'll get to see that in few minutes. So yeah, this is also a very common error, assigning to nil map. So at the time when we started with the map, that it was advised that we do not start putting entries into a nil map. We need to first do the empty initialization for that map. So if we like try to assign the value inside a nil map, so what this will do is this will also give us a panic, that is assignment to entry in nil map. Okay. And the first one, which is a nil pointer dereference, it is the most common thing which you will encounter while working with pointers in your program. So in case I have created a pointer variable, but did not initialize it or did not allocate any memory. So what this will do is, if I try to like call the ABS method on it, so this will try to call the ABS method on a nil object. So calling a method on nil object results in a panic. So as you can see, runtime error, invalid memory address or nil pointer dereference. So it was trying to dereference a nil pointer, and that's why we got this panic. Okay. So that was all about panics. So let's see how we can recover from panic. So occurring panic is also a common thing, because sometimes like this abnormalities can happen anytime in your program. Like you are not aware that you are sending a 0 as denominator value, or sometime you are not aware that you are trying to insert value into an empty map. So this type of panics can occur. So sometimes we want to handle panic and sometimes we do not, because panics are also helpful in understanding that something could go wrong or something has gone wrong and any abnormality has occurred. But sometimes when we want panic to be handled, like if we want to handle a panic, that we can do using the recover statements. So what recover statements do is it attempts to recover from a panic. So even if a panic has occurred, we can still control our program and stop the panic from propagating into another functions. So a recover must be, it is very important to keep this in mind, that a recover should be attempted within a defer statement only, because the normal execution flow of that function has stopped and only the defer statements are going to be executed when a panic occur. Okay, as we saw in the very first points when we discussed panic, that it starts unwinding the defer stack as soon as it hit panics, as soon as the function hit panics. So that's why it is necessary that we specify the recover mechanism into defer statement only. So in this given program, as you can see, I have created a defers anonymous function, and in which we are recovering from panic. So this is how we generally recover from a panic. We call this recover function. So this recover function will return whatever we pass to this panic value. Okay. So since I have since this is an interface value, that means we are passing an this panic accepts an interface, we can pass any kind of type to this panic function. So it will return the same value to this recover mechanism as well. So whatever, so uh, if our program encounters a panic, okay, and defer statement catches it, so it will get this value, whatever is sent into the panic function into this R variable. And this is general error handling mechanism, that if R equal to nil, just print the stack trace of error or whatever message we want to print after recovering the error. So let's see with the help of an example. So consider I have a foo function. Okay. In foo function, I am printing start of foo. Then after that, I have put a defer recovery mechanism into defer anonymous function. Okay. And after that, I have created a panic. Okay. So as soon as the panic hits, it starts rolling back it stops the execution. That means this end of foo will not be executed, and the defer stack will start rolling back. So the defer stack will start rolling back, and we will encounter that this recover this function, this particular value will get executed. This recover function will be called. A value will be fed into this R variable, and we will check if R is nil or not. So if this R is not nil, that means we were able to get some value from the panic, and we will we can do anything here. We can put the logs, we can put a stack trace here, we can put any print statement, whatever we want to do after recovering the panic. And this function will stop executing, foo function will stop executing and go to line number 9 in the main function, and it will continue the execution with the further line of further instruction at line number 10, since the panic has been handled here and it is not propagated further because of this recovery mechanism at place. So as you can see, first the print hello statement was executed. After that, it went into the foo, and in the foo, it print the start of foo string. Then after that, a panic was occurred. We sent a I am panicking value to this panic function, and after this, in the defer function, we recovered the panic. So since we recovered the panic, we were able to stop the propagation of panic here only, and it did not continue on in the main function. So here the print statement also got executed because this R value was not nil. We sent I am panicking value here. So this printed panic occurred and the value, that is I am panicking. And after that, it printed the value in the main function, that is panic and recovered. So this is how we write a recover mechanism in our functions, so that we can recover from panics. So it is to be remembered always that we need to do the recovery mechanism in the defer functions functions only, because defer functions are the only one which will be called after a panic has occurred. So we will be able to recover from it.
Hey, let's say we introduce another panic statement at line number 18. Then what will happen?
At line number what?
18.
18. Yeah. So this panic will go on with main function. Okay. So we see. Yeah, as you can see, this panic is propagated into main function now, because it created a new panic altogether, and this main go routine panicked after line number 9. So it was able to do the functioning up to line number 9, and it did not print anything at line number 10. Is it clear? Okay. So few things to know while working with recover. That recover call will return the argument provided to the initial panic. So if the program is currently panicking, okay, so as we just saw, if a program is not panicking, this R value will be nil only. So this R value will be nil, and this panic recovery thing, whichever we have done here, it will not be printed and it will not execute anything within this part. Okay. So we need to always send some non-nil value to panic so that we can know what has happened actually. Okay. And if the program is not currently panicking, recover will return nil value. Okay, so it does not have to like attempt trying to recover if a panic has not occurred. One thing to also keep in mind that we should not send a nil param to panic, since panic function accepts an interface value, so nil is also acceptable. So what this will do is, let's see with the example. So this will silently recover and will not do anything. Like, just try to run this. So as you can see, even though the panic was recovered, we were not able to see this value fmt.Printf panic occurred, because we passed the nil value to this panic function. So as I mentioned, that whatever value we pass here, we are going to get that in this R variable only. So since it is nil, it will not execute. But still panic has been recovered, so it will not get propagated. Okay. So these two things need to be keep in mind, that if we send a nil value to panic, it will not fulfill this particular R not equal to nil condition, because nil not equal to nil, this condition will not be satisfied. But still panic will be recovered, and the main go routine will not panic. Okay. And there is one more thing we can do is, we can like print the stack trace of our panic as well after recovering. So we can do that with the help of this debug.print stack method. So consider I have created a panic with a message invalid error occurred, invalid request body. I'll just put it. So what it did was, it went into the recovery mechanism. It printed whatever error we sent, like panic occurred, invalid request body. Then after that, it printed the stack of that panic. It printed the total stack, that means function calls, whatever went behind this panic. So it will print that all, and then it will just go on with continuing its execution. So you can see that line number 13 is also executed. So this is not similar to panic. This is just us writing the stack of that panic. Okay. This is just the stack trace we are printing and nothing else. So this is for our own information, that where that panic had occurred, we can debug it using this. We can debug it using this stack trace. So why panic and recover is important, because sometimes it is kind of easier to propagate an error by panicking and recovering rather than returning errors. So it is a possibility that error, we do not know as a developer that someone is going to handle error or not. So sometimes it is okay to like panic the program and then recover it later, so that we get the full idea that some error has occurred. Okay. And this is also helpful to get the developer attention, like for some cases where we saw the error occurred while we were trying to attempt to add values to nil map. So this was mainly to catch attention that we should not add values to a nil map, and instead we should do the initialization first. And sometimes also some condition may happen that sometimes the program cannot just continue on with execution. Like if we are writing a WebSocket connection for WebSocket connection for a HTTP server. So if WebSocket connection is not successfully built, so any information exchange is not going to happen. So at that time also we can like create a panic that uh, connection was not able to successfully build. And in such cases, we can use the panic and stop the execution of the program. And recover is helpful while stopping the program from crashing. So as we saw that panic just rollbacks to the topmost of the function execution stack and like crash the application. So in order to recover from that and not let that happen, recover is used, and we can use it to like stop the function from program from crashing. Okay, guys, so this was all about panic and recover. So let's take a 10-minute break and then we'll continue with the topics. Okay. So just do not leave the meeting. Be right back at 10:50. So I'll be starting with the next topic, and take some break for 10 minutes, and we will continue the session from 10:50 onwards. So let's get started. So the topic now we are going to discuss is context. So there is a package named context in standard library of Golang, which provides us a type context. So as the name suggests, it is just passing around context in our application. So this context package and its type is useful in cases where we are handling with HTTP requests or any sorts of request and response structure. So at that time, when we want to pass around some value related to request, like some important value like request ID related to request or some details of the request, at that time we can use this context package and its type. So you can get the documentation of this context package at the following place. I have attached a link to it. So since it is kind of an advanced concept, we will not go too much deep into it because there will be few concepts coming in the upcoming sessions, which are Go routines, channels, and HTTP programming in Golang. So at that time, you will get to know some basic stuff, which are the prerequisites for understanding concept, a context. But for now, we will just go through it briefly, and we'll see what are the main tasks or concerns that context package handles. So generally there are two things which are mainly handled by context, and they are context cancellation and propagation, and second is request scoped values. So while talking about request scope values, we can say that when we deal with HTTP requests, so there is a possibility that HTTP request can go very deep. So consider with the help of an example. So I am at a restaurant, okay, and I am giving an order uh, to get me a sandwich, okay. So in order to get the sandwich, they will take the request from me that I want a sandwich, and after that they will subsequently like perform some actions related to it in order to make a sandwich. So there is a possibility that that sandwich needs a tomatoes, and tomatoes are not there. So the chef could ask vendor to get tomatoes. So what is happening here is the context related to request is getting passed around from one place to another, like from me to chef, then chef to uh, the vendor, which is getting in the tomatoes. So at that time, this values should be propagated all together from one layer to another. So this is where this context cancellation and propagation is helpful. So if I want to cancel my order, so it is important for the chef and vendor, for both of them to know that I have cancelled the order. So when I cancel the order uh, to the chef, he will know that the order has been cancelled, and further instruct the tomato vendor also that we do not want the tomatoes anymore because the order has been cancelled. So this is how we in general handle the cancel and propagation. So similar we want to do with HTTP requests as well when we are dealing with it in a programming language. So when we are working with applications and we deal with HTTP requests, we need to also consider the cancellations as well, because we are putting valuable resources into action in order to perform some specific task. So consider I am requesting for some resources, which is sending me a huge file after processing it. So what happens is my backend application is working on like building that file, and it is deploying some important resources to get that file created and send it to me as response. But what if the request is cancelled in between? So at that time, the our application program should know that that request has been cancelled, and at that time the resources which are deployed in order to uh, give a response to that request should also be cancelled. So this is how cancellation and propagation should work in our applications as well. So that's where context package is very helpful. And there are some request scoped values which can be useful while working with HTTP request, like if I am like working on a request, so it must be helpful to have a request ID associated with particular request and print it in the logs, so that I know that this particular log belong to a specific request. So in that case, request scoped values are also helpful to us, and these two can be achieved with the help of context package in Golang. So you will get to know more implementation details in further sessions. So we are here just discussing the brief overview of this topic. So generally there are two functions in context package that allow us to create context object, and one of them is context.todo. This creates an non-nil and empty context for us. Okay, so if you want to go through the documentation for it, you can visit this website and you can check out what do we mean by non-nil empty error. You can go through the code as well, that go through the source code as well, that it is creating an empty context for us. So as we can see, this is a new method is called, an empty context variable is assigned, and this has been sent back to us. And similarly, we can create context using context.background method as well. This is similar to context.todo. This also creates non-nil empty context for us, but the difference is the intention here. Both of them have same functionalities, but context.background we use when we want to create more context out of it, when we are sure that we will be using this context. And context.todo is used when we are not sure that we will be receiving context from some another function, like as we talked about propagation of context in the previous slide, that we can like send the context layer by layer deep into our request. So if we are not sure that we will be getting context in some layer, so at that time we can use context.todo. So at just as a placeholder, even though functionality is same, everything is same with both context.todo and context.background, just the intention is different behind using those. And there are four main functions related to the task which we just saw, which are context cancellation and propagation, and context having request scoped values. So in order to assign request scoped values to our request context, our context we have with value function. So what this with value function does is, it takes a context as an input and it takes a key value pair, and it then attaches this key value pair to this context which we passed and created a new context out of it and return it to us. So just like I sent a burger and I wanted like a tomato slice in it. So I'll like just in the case of request, I'll also mention the key value pair, that whatever value I am assigning against the key. So if I want to have the request ID in my context attached, so I will use the key as request ID and I'll assign the value of the request ID in the context, and we'll create the new context out of it. So this newly generated context will now have this key value pair fit within it. And these three functions which we see at line number 2, 3, and 4, which are with cancel, with deadline, and with timeout, what these three functions do is, these three functions take care of cancellation and propagation part. So in order for us to able to cancel the request with the help of context package, we create new context, child context, with the help of these three functions, and we can set deadline to it, like after how much time, at what time exactly our context should expire. And with timeout function we can like create a context with the timeout, that after 30 minutes or after 2 hours of processing, our context should expire and should further process no more okay in the request. So these four functions are helpful with these two particular cases, that is request scope values and cancellation and propagation. So you will not have to use it anywhere, or you will not get to program with it until you get the hang of HTTP programming in Go. But just in case, for your knowledge, just keep this in mind that with value is related to having request scope values. We can add key value pair to our request context, and these other three, with cancel, with deadline, and with timeout, these are related to cancellation and propagation. So with the help of this, we can cancel or timeout our context. So yeah, as I mentioned that whenever we were using those functions with value, with cancel, with timeout, we were creating new context out of it, because context is an immutable object. We cannot like update the values in the context type. So we will always have to like create a new context around a parent context and add more data to it. So if I had a request context earlier and I wanted to attach request ID to it, so what I do in this case is I use the with value function, pass the parent context to it, and I assign the key value pair. So it will result in creating a new child context with additional data. And you can wrap around your context multiple times, and it will be it can be kind of represented into a tree structure. So let's look at it. So uh, what I'm trying to do here is I am trying to create a context which consists of few things. So let's go in the very innermost function, what we are doing. So first thing what we have is we have context.with value. So in the context.with value, what we are doing is we are passing in non-nil empty context using the context.background. So at the very top, at the very top of hierarchy, you can see that we have a parent context. Okay. And then after that, we have added a session ID to that particular context. So at that time, we have got a new context, child context with session ID. So this is at the second part. And after that, this function returns a new context, this context.value, and it will be passed on to this with deadline function. Okay, so this with deadline function will add a 30-minute deadline to the earlier created context. So now our context, which had session ID before, also now has a deadline of 30 minutes. So we have successfully added a deadline to it and created a new child context again. So you need to understand the hierarchy that we had a parent context we created using context.background. Then after that, we added a session ID and created a new child context. After that, we passed on that new child context and created a new context with deadline. And again, what we are doing is we are passing that child context to context.with value function, and we are adding request ID to it. So here we have created a third child context, which has all the value from before, and additional to that, we have a request ID also. And this particular child context at the fourth stage, which has session ID, request deadline, request ID, it is being sent to two different functions. One of them is trace function and one of them is logger. So we can pass around the context as well to the different functions after assigning values and deadlines to it. So this is how a tree structure of context would look like. And in order to understand the hierarchy, we can say that context represented as a directed graph. Each child context has access to values of its parent context. So as I mentioned, that context.background did not have anything, but the context.session added a new session ID. So after that, when we use this particular context in the request deadline part, the session ID was also accessible here. So at the very end, when we pass on context to this zipkin trace and request logger, we will have all three values in the context, that is session ID, request deadline, and request ID. So we can have access to values from parent context, and data access flows upward in the tree. So as we can say that this is the parent context and these are the child context. So we can say that data access hierarchy goes upward, so that request logger context will have the access for all the data upwards. Request context at this place at point of request id had the data access of session id request deadline. The context at point of request deadline had the access of session id. So this is what we mean when we say data access flow upward in the tree. And opposite to that, cancellation signal travel down the tree. So consider if I cancel the parent context, so the child context will also get cancelled along with that. So if I create a context dot background, and then after that subsequent contexts are created using it. So if I cancel this parent context, so all this contexts which are created below child context, these will all be cancelled. So as you can see, this cancellation flow is represented by gray edges, and data access flow is represented by black arrows. So let's look at a simple example. I'll just show you. So what I have here in this case is I have a client program. So I have a server which runs a HTTP server on my local system. So I will just do that. Okay, so it was already running. So let me do it again. So consider this is an HTTP server, like our application server, which is running. And I have a client. Client, that means whoever is calling that whoever is making HTTP request to that server. It can be browser, or it can be any client program sitting on other server. It could be anything. So generally when we like access websites and web application on browsers, so browser is the client there. So for just an example, you can consider this client as browser as well. So what this client is trying to do is it is trying to access the server at port 8080, and we will just see what is there in the server code. So what this server does is it takes the request, waits for 5 seconds, and then returns hello to the client. So we have started the server, and we will just run the client. So what this is doing is this is sending the request to server, waiting for 5 seconds, then the server is returning hello. Okay, so this was simple because this had only simple few things that we were able to send the request and we were able to get the response. But now we will see an example of context cancellation. So here my request had context cancellation as well. Okay, so in this particular program, what I'm trying to do is I am adding a context with timeout here, which will time out within a second. So as we know that our server is taking 5 seconds to send the response. So if my server is not sending the response within 5 seconds, within 1 second, so what this will do is this will time out and cancel the request. So let's try to hit that. So yeah, as you can see, it is showing that context deadline exceeded and it has exited the program. And on the server logs as well, you can see that server had request had started, but the context was cancelled in between because we timed out and the server ended the processing. So this is a general use case where like we can have context and we can use context cancellations. So yeah, this was a brief idea about context. You will get to know more about it when you will be looking at the HTTP programming in Golang, and some few more concepts like Go routine and channels, which like plays their part in background in order for context to work. So yeah, this was all about context. So further session will be carried on by Sushmita. Sushmita, you can take over. I'll stop sharing my screen now.
Yeah.
For reference, I'll share the code as well with you guys, just so you can just try it out for now. But you will get a clear idea when you go forward with other concepts. Okay.
So this was a bottleneck.
This meeting is being recorded.
Okay, so this was the bottleneck in Golang because it was not having any dependency management tool. So this type of issue also come into the production environment, and so the community started looking for the more approaches for the dependency management. So the Go models was introduced in Go 1.11 version. So prior to this, there was like vendoring and the dep, which community, it was a third-party tools, both were the third-party tools, and community was using them for the dependency management. So the vendoring and dep are being deprecated and they are not been used now. But let's just to give you more information about it. There were like pros and cons for vendoring and the dep. So what does vendoring concept does is like it creates a vendor folder into your code, and it stored all the third party dependencies into that vendor folder. So what was the pros with this approach is like whenever you try to build your project for the deployments, all the necessary dependencies were already present in the vendor folder. So the building type or the deployment time got significantly reduced. But there were many cons with this approach because it increased the code size of your project. Let's say the code size of Golang, the code size is, let's say the file size is 1 MB. The dependencies would be more than that. Like it would be usually more than 5 MBs because of storing all the vendor file code in your own projects. So there was also one of the con, like the multiple versions of the same package you were not able to use in your project. Let's say I'm using package X, and some of my dependencies are using 1.1 version and the others are using 2.1 version. So this was not possible using vendoring. Then it was not a good practice to make the third-party dependencies part of your code. And also the upgrading and downgrading the dependencies was bit difficult. Then we use the tool called dep. So dep is a third-party tool, and it is being used by many programming language. So it was also used by Go. So what dep does is like dep manages a dep file which has the versions of each dependencies. It was a much cleaner way of managing dependencies than vendoring, but it also had some of the cons as it needed to download the dep in your own system. Like you had to install and download the tool first and then start using it. Again, the one more problem with this approach was if you had any interdependencies, let's say we are using two repositories, let's say two repository X and Y, and both X and Y are also using a third-party tool as Z. And let's say X is using the version of Z as 1.1 and Y is using 3.1. Then in this case, this scenario was not possible to handle using the dep. Also, the dep file is not much descriptive to understand, like how does it manages the dependencies. So I think because of this multiple cons for the vendoring and dep, so the Go modules was introduced. So what is